Hello, and welcome to Cruising Through Calculus. My name is Alex, and today we're going to be looking at some complicated derivatives. Now, complicated is of course subjective here. What I mean when I say complicated derivatives is that we're going to be using like the chain rule, and then when we're using the chain rule, we're going to be needing the quotient rule. And then perhaps in the middle of that, we'll need another rule. So we're going to have a lot of work ahead of us. And I think that you'll see that most of the trouble here is just keeping our work organized and not getting overwhelmed. As long as you can keep your work organized and not let it overwhelm you, you should be okay. Before we jump into any examples though, I just want to tell you what you should know about finding derivatives already. Here's what I'm talking about. You should know that the derivative of a constant is 0, the derivative of x is just 1. You should know the power rule, the product rule, the quotient rule, the chain rule, and you should probably know at least these two derivatives of sine and cosine. We're going to be using all of these as we go through these problems. If you don't know these, I highly recommend writing them down somewhere, maybe on like a note card or a cheat sheet so you can refer back to them if you need to. With that, let's jump right in. For each problem, we're going to be following the same set of instructions. So it says differentiate each function with respect to the given variable. The reason why they word it that way is because we're not always going to be using x. In fact, in this problem, we're going to be finding the derivative with respect to t this time. Don't let that throw you off though. You're going to do all the same things that you would do if this was x. So let's take a look at this. The very first thing I notice is that we are dividing these two pieces here. So that immediately makes me think that we need the quotient rule. So let me write down the quotient rule here. And then let me identify the top and bottom pieces. Our top piece is the 3t cubed plus 4, quantity to the negative 3. And our bottom piece is the 2t minus 3. All right, now we need the derivative for each. Let me start with the derivative of this piece over here because this is actually going to be easier to find. The derivative of 2t minus 3 is simply 2, like that. Now let's come over here and find the derivative. Now, let's think about this problem as if it was a separate problem entirely. Forget that we even started here and are doing any of this stuff, and let's just pretend somebody said find the derivative of this right here. Well, what we're going to need to do is use the chain rule here, because notice that we're taking something that's more complicated than just t and raising it to the negative third power here. So identify the inside and outside pieces. The inside piece is 3t cubed plus 4, and the outside piece is to the power of negative 3. So following the chain rule, what we do is we find the derivative of the outside. So we take the negative 3 and bring it down. We leave the inside alone. Then we subtract 1 from the exponent. And then we multiply by the derivative of the inside, which is going to be 9t squared, like that. Now we could clean this up a little bit here. For example, negative 3 times 9 is negative 27. I'll put the t squared up front here. Otherwise, I'll leave it like that for now. By the way, when you're doing these problems, remember that you always need to subtract 1 from the exponent. I know that seems pretty obvious, but there are quite a few people who will write negative 2 here, probably because they're so used to just taking this number and simply reducing it. But remember, if you have a negative and you subtract it, it's going to get even more negative. All right, now we found the derivative of the top and bottom pieces. Let's put them into this formula here and see what we get. Okay, f prime is going to be this piece here. Okay, then we need g minus g prime, so that's just 2, and then f is this piece here. And then let's not forget, of course, this is all over g squared. So that's 2t minus 3 quantity squared, like this. All right, here's what we're going to do now. We're going to deal with these negative exponents next. And what we're going to do is we're going to make them positive by moving them into the denominator. Now when I do that, the other pieces here are going to remain in the numerator. And what I'm going to do is I'm going to take these two pieces and cram them together, and then this negative 2 will just stay in the numerator. So there's a couple of different things that are going on here. Let's take a look at this first part here. We have negative 27t squared, and then the 2t minus 3, over the 3t cubed plus 4 to the power of 4, minus the 2 is going to remain up top here. We're going to get 3t cubed plus 4, and this one is to the power of 3. And this is all over this piece here. like that. Okay, now, if you look up here, these almost have the same denominator. In fact, if I take this piece over here and if I multiply it by 3t cubed plus 4 over 3t cubed plus 4, that will get us the same denominators because the bases are the same and I can add the exponents to get 4. So let's see what happens when I do that. Okay, the denominator is going to be the same. So we're going to have the 3t cubed plus 4 to the power of 4 after I multiply that. We're going to have negative 27t squared, 2t minus 3, minus 2 times this piece here, 3t cubed plus 4. That's going to be over 3t cubed plus 4 to the fourth, and all of that is over 2t minus 3 squared. Whew, like that. Okay, next what we're going to do is we're going to distribute this here. We're going to distribute this here. And there's one other thing I'd like to do as well. I don't know about you, but it's kind of annoying taking this part here and doing all over 2t minus 3 squared. So what we're going to do is we're going to take this part and we're going to multiply by the reciprocal at the end. So let's see what that looks like. Okay, so negative 27t squared times 2t is negative 54t cubed. Then we're going to have 81t squared. Then over here we're going to have negative 6t cubed. And then negative 8 over 3t cubed plus 4 to the fourth. 3t cubed plus 4 to the fourth times the reciprocal of this piece. So 1 over 2t minus 3 squared. All right, we're extremely close to being done here. Let's take a look here. I notice that there are two pieces in the numerator that are like terms that we can combine. That would be this piece and this piece here, the ones with the t cubes. Since we're multiplying here, the top is just 1, so I can just ignore that basically, since 1 times anything is anything. In the bottom here, we're multiplying, so we can just push them together basically. Okay, so we have negative 54 minus 6. That'll be negative 60 t cubed plus 81t squared minus 8 all over 3t cubed plus 4 to the fourth, and then 2t minus 3 squared, like that. And that is our answer to this problem. Let's see if we can find the derivative of this function here. And the very first thing I notice is that we're multiplying these two pieces. So that tells me we need to use the product rule. So let me write down the product rule here. Then let me identify the two pieces that are being multiplied. And then we're going to find their derivatives. Okay, the derivative of this first one is quite simple. That's just negative 5. The derivative of this one over here is a little bit more complicated though. That's because this whole piece here, which is more complicated than just x, is being raised to the 5th power. So we got to use the chain rule. We're going to bring down the 5, leave the inside alone, subtract 1 from the exponent, and then multiply by the derivative of the inside like that. All right, let's take these and let's start putting them into this formula here. So our f prime is negative 5. Our g is the top right piece there, plus g prime. Now when I multiply this out, I'm going to do 5 times 10x to give me 50x, and then the 5x squared plus 2 to the fourth will still be there, times f, which is negative 5x plus 2, like that. All right, now we can distribute this piece here, and we can distribute that there. I cannot distribute this negative 5 into here because it's being raised to the power of 5. And if I tried to do that, I'd be going outside of the order of operations. You've got to do exponents first before you multiply, after all. Okay, so let's start multiplying and distributing. We've got a negative 5 in the front here. Not much I can do with that at the moment. Here I have 50x times negative 5x. That'll be negative 250x squared with this piece attached. And then plus 100x with that piece still attached. All right, now as I look through this, I notice that there is a 5x squared plus 2 and a 5x squared plus 2 and a 5x squared plus 2 present in every one of these terms. So I'm going to factor a 5x squared plus 2 to the fourth out, because that is the GCF here, to the fourth. Okay, let's see what that leaves us with. We have our negative 5 here. Now this piece, I took 4 of them out, so that leaves me with just 1 of them. And let's see here, these pieces should both just be gone at this point. Like that. All right, now, let's go ahead and distribute this negative 5, which we can do now. So we get negative 25x squared minus 10 minus 250x squared plus 100x. Of course, this part is still here at the beginning. And then let's see here. Is there anything we can do? Ah, check this out. These two are like terms, so we can combine them. Let's do that. All right, so when I combine these, I'm going to get negative 275x squared. I'll put the 100x right here, minus 10. And of course, this part is at the beginning. Whew. All right, there's only one more thing that I can see to do here. If you look over here at these three terms, all of these are divisible by 5. So what I'm going to do is I'm going to factor a negative 5 out from there. I'll put that at the beginning here. Okay, so let's see what we're left with here. That should be 55x squared. This should be negative 20x, and this should be plus 2, like that. This is our final answer down here. For our next problem, we're going to be finding the derivative of this function here. Now, you might think to start off with the quotient rule because you do see two things being divided here. But notice that outside of that, we have this being raised to a power. In other words, what we have here is a chain rule problem. So let's go through the chain rule here. What you're going to do is you're going to take the outside piece and find the derivative. So that means we're going to take our 1/3 and then we're going to subtract 1 from this, which will give us negative 2/3. You're going to leave the inside alone here. And then we have to multiply by the derivative of the inside. So what is the derivative of the inside? Well, we're going to need the quotient rule here. So I'm going to leave this blank here just for a second, and I'm going to come down here and I'm going to write out what the quotient rule is. Then I'm going to identify the top and bottom pieces and find the derivative of each of those. Now that I have these, I can put them all together using this formula here. So we have f prime g minus g prime f all over g squared. All right, so let's take a look here and see if we can simplify this a little bit before I write it up here. Because once I write it up here, this is going to be my full answer. So first, I notice that we can distribute this 4 here. We can also distribute this negative 4t cubed over here. So let's see what we get when we do that. Let's see here. We're going to get 4t to the 4th minus 20. Then we're going to get minus 16t to the 4th, and then minus 4t cubed, all over our denominator squared. Almost forgot to write that squared in there. All right, now, we can combine things. Take a look here. We have 4t to the 4th minus 16 to the 4th. Okay, so let me do this. When I combine these two, I'm going to write out my answer up here. So it'll look like this. We have negative 16t to the 4th plus 4t to the 4th, which is negative 12t to the 4th. Then we have our minus 4t cubed. Then we have our minus 20. And all of that is over our denominator squared. Like that. Now I would say that this is our answer right here. Now having said that, let's see what it would look like if we try to simplify it. I immediately notice that we have a power of negative 2/3 here, and that's being applied to this piece right here. So here's what I'm going to do. I'm going to take that piece right there, and I'm actually going to flip it because of the negative. I'm also going to do this too. I'm going to take our exponent and apply it to each piece individually, so it'll look like this. 2/3 and 2/3. Now this is still being multiplied by this over here. And the good news is we are multiplying here, so that means we can multiply across the top and the bottom. So let's do that. We're going to get, let's see here, t to the fourth minus 5 to the 2/3, then times negative 12 t to the fourth minus 4t cubed minus 20. All of that is going to be over 3 times 4t plus 1 to the 2/3 times t to the fourth minus 5 quantity squared, like that. All right, now let's take a look and see if there's anything else we could do. And actually, there is one more thing we could do. I was looking at this, thinking about it for a second when I saw it. We have t to the fourth minus 5 to the 2/3 over t to the fourth minus 5 squared. Imagine for a second that instead of t to the fourth minus 5, we had something like this, x to the 2/3 over x squared. We can actually simplify this. We can bring this down here and subtract the exponent, so it would be 1 over x to the 2 minus 2/3. And 2 minus 2/3, let's see if we can figure out what that is. We're going to need a common denominator here, so I'm going to have to multiply this by 3. We're going to get 4/3. Okay, so I think I know what my final answer is going to be. I'm going to take this piece and simplify it with that piece, leaving us with t to the fourth minus 5 to the 4/3 in the denominator. So let me take this, move it up here, and write down what my final simplified answer is going to be. All right, I've moved this up here, and now we can finally subtract these here. So this will cancel with this, leaving us with 4/3 as our exponent down here. So we're going to get negative 12 t to the fourth minus 4t cubed minus 20. All of that divided by 3, 4t plus 1 to the 2/3, and then t to the fourth minus 5 to the 4/3, like that. If you take a look in the numerator here, all of these numbers are divisible by negative 4. So why don't we take a negative 4 and factor it out here? Like that. Whew, I'm pretty sure that's where we're going to end it here. Knowing when to simplify and when to continue simplifying is a little bit of an art. I think that a lot of times teachers won't expect you to go quite this far, but every once in a while there will be a teacher that wants you to do all this work. In fact, sometimes there will be multiple choice questions where the multiple choices will look like one of the simplified answers. I think you can see here that finding the derivative isn't actually the most challenging, or maybe I should say the longest part of this problem. Most of your time is spent just working through all of the algebra. Let's see if we can find the derivative of y equals the square root of t cubed plus 2 over negative t squared minus 5. Now, one of the first things that you usually want to do in your calculus class is if you see a radical, change it. We're going to change it to a fractional exponent here. That is to the power of 1/2. All right, now in order to find the derivative here, we're going to need to use the chain rule. Notice the entire thing is being raised to the power of 1/2, and the thing that's being raised to the power of 1/2 is more complicated than just t. So let's bring down that 1/2, leave the inside alone, subtract 1 from the exponent, and then we have to multiply by the derivative of the inside. Now I can't just find that super quickly here, because this is going to be a quotient rule. So let me write down the quotient rule here. Let me write down our f and our g pieces, and then let's find the derivative of each of those. Perfect. Okay, let's take these and plug it into the formula. It's going to be f prime g minus g prime times f, all over g squared. Like that. All right, next, let's go ahead and distribute here and see if anything combines. Now over here I see a negative and negative, so that's going to be a positive when we distribute that, so let's remember that. All right, let's see what we get here. We're going to get negative 3t to the fourth, minus 15t squared. Over here we're going to get positive 2t to the fourth, and then positive 4t. And of course, this is all over negative t squared minus 5 quantity squared, like that. All right, now, it does look like we can combine some like terms here. I do notice that we have a negative 3t to the fourth and a 2t to the fourth. So that'll give us just a negative t to the fourth. So let's take that, combine those two, and I can finally write this up here. Because remember, we were trying to find the derivative of the inside piece, and this is it here. So we're going to multiply by negative t to the fourth minus 15t squared plus 4t all over this part here. All right, so let me erase this, and then we're going to see if we can try to simplify this further. Okay, so I notice a negative exponent here. Let's deal with that. We can apply it to both pieces and then flip them. So I'll do that all in one go here. We're going to get 1/2. We're going to get the negative t squared minus 5 to the power of 1/2 over t cubed plus 2, also to the power of 1/2. And these are being multiplied by this over here. So what I'm going to do is multiply it. So this top piece is going to be multiplied by this top piece here. And then this will be multiplied by this. And remember, these flipped when we did that. All right, this is good. I think we're getting extremely close here. In fact, there's another thing I notice. If you look in the numerator and denominator, we now have a negative t squared minus 5 to the power 1/2 and a negative t squared minus 5 squared. So imagine for a second that we had x to the 1/2 over x squared. That would be x, or 1 over x squared minus 1/2, which would be 1 over x, let's see here, 2 minus 1/2 would be 3/2, like that. So what's going to happen over here is that this piece will cancel with this piece here, and we'll be left with just 3/2. All right, so let's write that out. On the top here, we're just going to have this negative t to the fourth minus 15t squared plus 4t. And in the denominator, we're going to have 2, t cubed plus 2 to the 1/2, and negative t squared minus 5, this time to the 3/2. Actually, I just noticed something. Up here in the numerator, all of these have a t. So why don't we factor out a t? In fact, I'm going to factor out a negative t since it starts with a negative here. So we'll get t cubed plus 15t minus 4 all over the denominator. There we go. That's better. Like that. All right, let's see if we can find the derivative of this function here. Now, I immediately notice that the denominator has a cubed root, so I'm going to immediately rewrite that as the power of 1/3, like this. All right, now it's time to figure out which kind of rule we need. And I see that we are dividing these two here, so my very first thought is we're going to use the quotient rule. All right, well, let's go ahead and figure out what the top and bottom pieces are. Our top piece is the 5x to the 5th plus 2 to the negative 2. And our bottom piece is the 3x minus 4 to the 1/3. Now we need to find the derivative of each of these pieces. And each piece here is going to require the chain rule. So let's use that. We're going to take the negative 2 and pull it down, subtract 1, and then multiply by the derivative of the inside. That will be our first derivative. We're going to do the same thing over here. Take the 1/3, pull it down, subtract 1, and then multiply by the derivative of the inside. Now I also notice over here we have a 1/3 and a 3. So 1/3 times 3 is 1, which means those two will go away. Here we have a negative 2 times 25, so that'll be negative 50 x to the 4th times this piece here. All right, now I think it's time to plug everything into our formula. So our f prime is this piece. Times g, which is that piece up there, minus g prime, which is this piece here, times f, which is that piece up there, all over g squared. Like that. Whew, okay, now let me take this and move it up here and see if we can simplify this further. All right, I actually did change one thing when I moved it up here. We had 3x minus 4 to the 1/3 squared, so I took the 1/3 and the squared and multiplied them to get 2/3. Now, let's take a look at the rest of this. I think what I'm going to do here is I'm going to take these negative exponents and make them positive to see what happens. So here, the negative 50x to the 4th is going to remain in the numerator, and we're going to take the denominator here and make that a positive exponent, like this. Now, we are multiplying by this piece over here, which has a positive exponent, so I'm going to put that up top here like this. Okay, then, if we keep going over here, we're going to do the same idea. We're going to take this piece and put it in the denominator, and this piece and also put it in the denominator. Now remember, all of this is divided by this piece here, but what I'm going to do is I'm going to multiply this entire thing by the reciprocal here, like this. All right, now let's take this and multiply it out. We can distribute it to each piece here and here. And we only have to multiply this by the denominator part here. So let's see what happens when we do that. Over here, the numerator is going to stay the same. The denominator is going to be multiplied by this piece here. And then that's going to happen over here as well. Now notice we have 3x minus 4 to the 2/3, and we're multiplying it by 3x minus 4 to the 2/3. Anytime you're multiplying and the bases are the same, you're going to add the exponents together. So what we're going to get here is 3x minus 4 to the 4/3. Like that. Okay, so I pulled this up here, and as I was doing this, I noticed something. The 3x minus 4 and this 3x minus 4 are the same pieces, at least inside the parentheses. And the 5x to the 5th plus 2 is the same as the 5x to the 5th plus 2, also in the parentheses. If I want to combine these together, I need to make their denominators the same. So here's what I'm going to do. I'm going to take this side over here, and I'm going to multiply it by 3x minus 4 to the 2/3, like this. Because when I multiply this and this together, I'm going to have to add the exponents together, and I'll get the 4/3. Over here, I'm going to multiply by 5x to the 5th plus 2, like this. Because this is to the power of 1, and when I multiply these two together, I'll have to add their exponents, and that'll give me 3. So when I do that, I'm finally going to have the same denominator on each side. Okay, now, let's take a look here. I'm also going to have to multiply this by this up here. And I notice that we have a 3x minus 4 to the 2/3 and a 3x minus 4 to the 1/3. So when I multiply those, I also have to add the exponents. And 2/3, let's see here, 2/3 plus 1/3 is just 1. So here's what we're going to get. We're going to get negative 50x to the 4th times 3x minus 4 to the power of 1 minus this piece over here, 5x to the 5th plus 2, all over the denominator, which is 5x to the 5th plus 2 cubed, and then 3x minus 4 to the 4/3, like that. All right, we're getting very close to being done here. Let's go ahead and take this and this, actually, and let's distribute here. Okay, so negative 50x to the 4th times 3x is negative 150x to the 5th, plus, that'll be 200x, minus 5x to the 5th minus 2 all over the denominator. Let's see, that should be 4/3. Ah, look at this. I think we're nearing the end here because I have negative 150x to the 5th minus 5x to the 5th. That's going to be negative 155x to the 5th plus 200x minus 2 all over that denominator there. Okay, I think we're finally at the end here, believe it or not. Wow, that was quite a bit of work we just did. In fact, I would say that finding the derivative was actually kind of the easy part. Simplifying was the tough part, and as you can see, there was a ton of algebra that we needed to do in order to simplify these. Having a strong foundation in algebra is going to help you immensely when you're doing complicated problems like that. Just remember that when you're doing these problems to stay calm, cool, and collected. Always give yourself plenty of space to write out all the problems, and remember all of your algebra techniques because you're going to be using basically everything that you've learned in algebra when you're simplifying these problems. Now, organization is key here, so make sure not to write out sloppily and crazily because you're going to forget where you are from step to step. Organization really will be the key to doing well with these problems. If you found this video helpful, you might consider checking out my website, which is linked in the description below. You'll be brought to Infinity Learning Academy, where you can find Cruising Through Calculus. At Cruising Through Calculus, we have over 100 videos and documents to help you get through your calculus class, including videos for each topic, practice problems, and full video solutions for those practice problems. I hope to see you there, and together we can cruise through calculus.